Okay. All right, cool. So I'll start. Yeah, also, if there are any questions, feel free to ask me, just stop me in the middle. That's no problem. So welcome to the second workshop. Last time we talked about stuff like variables, then types of data, floats, lists, integers, and we also talked a bit more about lists, what a list is, how to add stuff to a list, how to append, that's the word, how to find the length of a list and stuff like that. So let's first do a quick recap, and then we can move on towards the topic. So for instance, last time we said that a list is defined as between two square brackets with each element being separated by a comma. And if you wish to append or add another item to the list, all you have to do is just do the list name dot append and the item. And so once you print the list, you see that now you have an additional item, namely the number 600. So that's good. Then last time we also talked about indexing, where we saw that the first element is indexed by the number 0. And so to print the first element of the list, all you have to do is just call it by its index. So as you can see here, I'll zoom in a bit, that's easier, yeah. So all you do is, just type 0, and that gives you the first element. If you type in the index 1, that gives you the second element, and so on. And last time we also talked about how to find the length of a list, which is namely we call the len function called len, and we just input in the list, and then that gives us the length, like how many elements there are inside the list, which are 6 here, which is correct. Last time we also briefly talked about the range function. I'll talk more about it now. So the range function is just a function that gives us integers between a fixed range. So for instance, by a default, it starts from 0 and goes up to the number which I put here. So for instance, here I say range 10. So it starts from 0 and it goes all the way up to 9. So this number, which I input into the function, is not included. So that's one point to keep in mind. So yes, and so this range function is quite important because it readily gives you all the integers between those two numbers you want. However, you can also change by you want every second integers. For instance, if I want all the even numbers between 0 and 10, all I have to do is just put my bound. So there's first bound 0, a second bound 10, and then this 2 just tells me what is going to be the spacing between each integer. So here it's 2, so that's why I get a list of 0, 2, 4, 6, 8. Makes sense. If I just change this to, I don't know, maybe 11, let's do 11, 20, it's going to give me, so it's going to give me it's going to give me integers spaced at values of 2 in between those two bounds. And same for here, say for between 0 and 10, and spaced in values of 3. And so that's why we have 0, 3, 6, 9. So okay, that's sort of a quick recap. Now we can move on to the next topic. So last time I briefly mentioned about how that sometimes there's a specific function that isn't inbuilt into the code already. And so that's why we have to import an external package, which has those extra functions. So last time, if you remember, we imported this package called as math, and we did import math, and then we used the square root function of math to find the square root of a number. And so that's so importing packages is a very important part of coding, because most of the times you will need to use those extra functions which aren't inbuilt in the code already. And so for in my opinion, I think NumPy, which is a very popular package, is by far one of the most important packages you will ever have to use in your life. And also matplotlib. So first, so NumPy is just a computational package. It helps you do computational stuff very easily. And matplotlib.pyplot So what is happening here is that this matplotlib is actually the name of the entire package, but we're just, we just want a sub package called pyplot. And that's why I say import matplotlib.pyplot. And yeah, so this is the syntax one uses to import an external package. And it's quite intuitive. Like, we import, which is the command, and then we just type the name of the package. So it's fairly simple to remember. And so, for instance, the sines and cosine function, they aren't inbuilt in Python. And so once I import NumPy, I get those functions with NumPy. So as you can see here, once I import NumPy, I can print what is the value of, say, sine 0 and cosine 0. So, so I first call the package NumPy, and this dot sine means that I'm calling the function sine, which is part of the package NumPy. So if you hadn't imported NumPy, then this function would not run. So you know what, we can actually try that. I'll show restart, okay. And so for instance, if I were to just do this, it says that NumPy is not defined. But then if I first import the packages and then I run this, then it runs, which makes sense. And so again, it's key. Sine 0 is 0, correct? And cosine 0 is 1, which correct, makes sense. So okay, so that's basically how you like import packages. But one thing is that like every time you will want to call a function from a package, you will have to type the package name dot, then a dot, and then the function's name. And if the name of the package is very long, for instance, this matplotlib.pyplot, like that's a fairly long name, and you don't want to be typing that every single time. And that's why we assign like nicknames to these packages. For instance, I will import NumPy as NP. So like this syntax again is very intuitive. Like, it's like what I would say in English. Like I'm going to import this as this name. And so if I import NumPy as NP and import matplotlib.pyplot as PLT, where, again, like these NP and PLT, these are just like placeholder names. And so later on in the code, when I'm using their functions, all I have to do is just type that nickname. So for instance, again, what I did above here, I can do the exact same. So so instead of being numpy.sine, it's going to be just np.sine and np.cosine. So, I first run this part, my bad. Yeah, so first I've run this part and then it's going to run. So yeah, having these nicknames is very important. Also, just a note, a very important note is that one should be consistent with these nicknames. So these like numpy.np and plt, these are like, standardly accepted names. And so like, if you like look up any code online, people are going to be like using these short forms. So you still have freedom up like, what you wish to do, but I highly suggest that you stick with these names because it's going to make your life easy. Because, like when you like show your code to somebody, then they will like know, oh, that's NPO, good. And like also being consistent with yourself is also important, because then you like won't forget what you named the package. And so that's why I highly recommend just like sticking to these names, which I have here, because those are the standard names. But okay, that's about importing packages. Now let's go to a bit more about these packages. So let's first focus on NumPy. So NumPy, as I said, very useful for scientific computations. We'll right now be specifically talking about two functions part of this package called numpy.array and numpy.linspace. So first, what is an array? So an array is actually just like lists. However, they're just like better things when it comes to doing computation. So they're kind of like matrices, one could say. So, so first, how do we define an array? So we call the function numpy.array. So this array function is part of the package. And then I just input in a list, like, our list that we talked about earlier. And that's going to give me the corresponding array. So for instance, here's an example that if I have list 1, it's with like, with elements 1, 2, 3, and if I want to transform this into an array, like all I have to do is just do numpy.array and then input in the list as like the input of the function, and that gives me the corresponding array. And so if you can see here, if I print the type of this object called R1, it's going to give me numpy.array. And if I print the type of list, it's going to be type of list. So you see that though they have like the same numbers inside them, they're like different kinds of like objects. One is an array, one is a list, and yeah. And turns out that they're actually quite different as well. So so now say we wish to do like, some computation with these numbers inside these lists. So say, let's just take this list one we have here above, which is just 1, 2, 3, and say you want to add these numbers into, just like add the numbers with their own numbers here. And so one might expect that it's just going to be list 1 plus list 1. That might give me 2, 4, 6. But then thing is with lists, I didn't run this part, my bad. I should run, yeah, okay. Yeah, so the thing is that with lists is if you like just do this plus sign, it's going to like kind of combine the lists and like not add individual elements, which one needs in this case. And same for like, and same for multiplication, like is 1, 2, 3 list, if I do that times 2, it's not going to give me 2, 4, 6. It's going to give me 1, 2, 3, 1, 2, 3, which is something that we don't want now. And so in this case is where arrays are super helpful. So for instance, if I want to add 2 lists, which have, like the same number of, so say if I want to add 2 lists, then I would first convert them to arrays and then add them. So for instance, here, if you do R1 plus R2, that's going to give you not what a list would give you, but it's going to give you the addition of the individual elements. As you can see here, 1 plus 5, 6, 2 plus 10, 12, and 3 plus 15, 18. Same for like, same for multiplication. So if I can multiply 2 arrays that have like the same length. And so what that does is that it's going to take the multiplication of the corresponding element. So the first element is going to be multiplied with the first element and so on. And I can also like, find the square of an array. So if I do like just raise it to the power 2, it's going to find the square of each element inside the array and then return the new array, as you can see here. 1, 2, 3 turns into 1, 4, 9. So that's why it's very easy to use. It's very easy to use arrays when it comes to like doing computations on like a list of numbers or like a massive array of numbers. And so that's why these are very useful. Also, it's quite easy to like translate between lists and arrays. So as you can see here, if you want an array, so if you have an array 1, if you want to go back to a list, all you have to do is just do list and inside it put array. That's simple. And as we talked earlier, like if you want to go from a list to an array, it's just going to be numpy.array, and then you input the list in the function. So yeah, it's quite simple to go back and forth. Okay, that's about arrays. Now we can move on and talk about numpy.linspace. And also, once again, if there are any questions or if I'm going a bit too fast, just stop and ask me.
None in the chat.
Okay, cool. Thank you. Okay, the next function is numpy.linspace. So this is also a very useful function, and one could say that it's like a more general version of the range function that we talked about earlier. And so the basic structure is as follows. So numpy.linspace has mainly 3 arguments, A, B, C. Okay, and by arguments I mean like the input. So it's just like a math, so each function, it takes in a few inputs, which are also called as arguments, and it gives an output. And so all these, so when I say the word function, that's what I mean. Like it takes in an input, it could be 1 input, 2 input, 5 inputs, and then it returns again 1 output or 2 outputs, so yeah. Okay, so here we input in 3 arguments, A, B, C, for instance, where the first one is going to be the starting point. The second is the ending point, and the third one is number of equal subdivisions. So what this is going to output is it's going to give me an array of C number of equally spaced points between A and B. So a more concrete example of this, for instance, is here, numpy.linspace 0, 1, 5. This gives me an array from 0 to 1 with 5 equally spaced points. So if I run this, it gives me, 0, 0.25, 0.5, 0.75, and 1, which are 5 points, and they're equally spaced, which is good. Same for, numpy.linspace 0, 10, 30. That's going to give me an array between 0 to 10 with 30 equally spaced points. And, there's like no upper limit on like how many equally spaced points you want. So for instance, here I ask for 100 points, and it still gives me. And yeah, so if I do like, as we mentioned last time, you can assign like a list or like an array to like a variable. So here I assign the corresponding array to the variable ARR, and this R is going to be an array. We can actually, I can show that actually. Yeah, that's better. So R, for instance, here, and if I do type array, it's going to give me like an array. And if I print the length, we should expect to be 100 because we asked for 100 equally spaced points, and it isn't return. So yeah, so which is good, makes sense. So that's basically about numpy.linspace. Then another function about another good thing about NumPy is that they come inbuilt with like some constants. So for instance, pi or e. We'll probably be using pi a lot lately. So yeah, so that's why you can see just like doing numpy.pi, that gives you the value, same for e. So yeah, that's quite useful. So yeah, so here I just like, mentioned a very, very brief introduction to NumPy. And like these are like, in my opinion, like the sort of main functions, but there are like countless more functions. It's like just, it's crazy like how many functions there are. And so, yeah, so this is not the entire picture, just a very, very brief picture of NumPy. But yeah, we will talk about more functions of these packages as they come up. So yeah. Okay, so we talked about NumPy. Let's talk about matplotlib. So matplotlib is also another very, very important package. This is basically what you will do to like make plots. And like, as you may know, part of like any science is making plots. And so this is going to be a very crucial part. So here I'll like, just briefly talk about it, like just like, how to make a simple scatter plot. But Will, on Monday, we'll be talking about this in more depth. So here's like just a brief, like, introduction. So there are namely two kinds of plots I'm going to talk about now. That is a scatter plot and a line plot. So by a scatter plot, like I just mean like, just like if you have 20 points, then you like plot them as individual 20 dots in the plot space. So that's just a scatter plot. And a line plot is just that when you plot these dots, it's going to connect these dots by a line. So that's just called a line plot. And so, just to start things off with, let's plot a very simple thing. For instance, let's plot these 5 values of x and their corresponding squares. So as you can see, the x values are going to be 1, 2, 3, 4, 5, and y values are going to be the squares. And the way I plot is that I first call my package. So as you remember right here, I imported as plt. And so I first call the package plt, and then I call a function which is part of the package called as scatter. So and the scatter name is because we are plotting a scatter plot. So it's fairly easy to remember. And so I do plt.scatter, and then I input in the x and the y points, and then I just do plt.show. It shows me the plot, and so that gives you those 5 points. So that's pretty good. So again, now we can plot stuff. Awesome. So yeah, so this is a scatter plot. If you want to do the same plot but for a line plot, all we do is we just change the function we are using to plot. So here we use scatter. Now we're just going to use plt.plot. And that gives me like, the same function, but now these dots are joined by lines. So like, if you look closely, this point is connected to this point, then this point, and so on. So yeah, this is a line plot. So cool, okay. Now we can also like use our knowledge of NumPy functions to like plot something cool. So for instance, okay, let us first make an array of angles between 0 to 2 pi. Let's say 100 angles, for instance, and let's plot the sine and cosine functions. So, okay, so these, yes, okay, so here my x is going to be the angle, so it's going to be my angle, so it's going to be my angle array called thetas, and so I plot that as the x argument here, and the y argument is going to be the sine of these angles. And as you can see here, I plot as a scatter plot the sine and the cosine functions, and I see that I get these sine and cosine curves as we should expect, which is good. However, there's, so thing is, okay, with coding is that, sorry, with Matplotlib is that it is able to identify that we're trying to plot two things on the same plot, and that's why it changes its color automatically. But again, like, on Monday we'll talk about it more, like how we can manually change colors and stuff like that. But yeah, so also, like, as you might have guessed, this is a very bad plot because there are no legends, like, is the blue a sine or a cosine, or what is it? It's like, now we know what a sine function looks like, so it's easier to tell here, but having a legend is also like a very important part. So this is in that sense a bad plot. But yeah, also, yeah, here we do a scatter plot, but it might be more appropriate to use a line plot. And so if I do the same thing again, but I do a line plot, I get these smooth curves. They look pretty good. That's nice. And yeah, like I can, like, also add like an X label. So for instance, it's like, it's like a very brief, like just introduction. Like I probably will mention this more on Monday, but just like give you a feel for like how. So for instance, if I put an X label of X, it gives me a label here. So it's pretty fun to like make plots and stuff. So yeah, that's cool. So yeah, so that's about coding. Yeah, and also, yeah, I think for me, making plots like that is the best part of coding. Like it's just like so fun to like find the perfect combination of colors and like size of the plot and stuff like that. So yeah, it's quite fun. So yeah, so that's all about plotting. Or I'll make a quick break here and to ask if there are any questions. Are there any questions in the chat? Oh, I see something in the chat. Oh, okay. Are angles in Python always radians? Good question. So thing is, okay, so we are right now using the NumPy package and these NumPy functions like sine and cosine, and they are like inbuilt into the package. And so I believe that these packages are built in a way that they input in by default radians. But I think there might be like additional stuff that may change it to the degrees. Yeah, change it. Okay, that's good. Yeah.
Yeah. So if you do np.sine Raj, like in a.
Yeah.
Like this is a really useful trick, by the way. Yeah, you can see what arguments a function takes.
Yeah, perfect. Yeah, thank you, Will. Yeah. And so if you can see, as you can see, X is what we're trying to input in. So it says angle in radians. And I think it also has additional arguments somewhere for if you want to input in an angle in degrees. I don't.
Yeah, it's actually.
I think it should have. I don't know. I feel like.
In any case, multiply by pi over 180.
Yeah.
180 over pi.
Yeah. So yeah. So with these packages, they come by default with radians, but it's like just with these specific packages. Like it's not like an entire Python. You just have to use radians. Like that's not the case. It's just with these functions that we're using that they have to be in radians. But yeah. Are there any other questions? If not, you can always ask me. I'll move on ahead because we have some important ground to cover today. So Now we're going to talk about conditional statements and loops. These are also the backbone of coding. Like this is like basically like what you're going to be coding in most of your time, like just making for loops and if statements and like, loops and stuff. Yeah. And so also one nice thing about coding in Python is that the syntax is very intuitive. Like for instance, as you saw with importing packages, it's like, it's import numpy as np. Like it's like English, it's very like, it makes sense, the code. And so it's the same with these loops and statements. And so that's why Python is known to be like a fairly easy language to learn. So yeah, okay. Let's start with the first, that is the while loop. So again, the idea is very simple. It just says that while some condition is true, we ask the code to do this. So, for instance, if I uncomment this and I say, so, okay, while 0 is less than 1, print that sentence. And so as 0 is always less than 1, at least in our universe, which is true, this statement is always going to be true. And so if I run this, what's going to happen is it's going to run forever, basically, until my laptop crashes. So I'll have to stop this soon, but as you can see, just printing sentence over sentence on and on and on with no stop. And this asterisk symbol here, that tells that this cell is being running. And so it's still printing like sentence over sentence. So that's basically a while loop. I should stop this because otherwise my laptop might crash. But okay, yeah. So that's a while loop. We can also have other while loops that, for instance, while 123 is equal to 123, print equal numbers. And we know that this statement is always true. So, if I run this, it's going to print, again, equal numbers on and on. So that's a while loop. Okay, one important point here. So when you make statements about equality in code, it's not a single equal to symbol, it's a double equal to symbol. And so just, be like aware of that. So if I just do equal to, it's probably not going to work. Yeah, it says invalid syntax. So that's why you should always have two symbols. Oh, I should stop this. I don't want this running. Okay, yeah. And same for if while 123 is not equal to 123, so this symbol here means not equal to it. But thing is, this statement is a false statement. Like this is not true. And so as it's a false statement, this while loop is not going to run. And so that's why we see that nothing is printed. And also, same for like if 3 is more than -2, if I run this, it's going to run again. So yeah, this is basically while loops. Not very, hard, pretty simple. And another nice example of like a while loop is this right here. So this might be a bit, it's not hard per se, but it's a bit more like, it's a bit more involved. So, okay, so let's call a variable called I, and let's start with it being labeled 0. Now we want the condition that as long as I is smaller than 10, it should run the while loop. And so at the start, as I is equal to 0, this statement is true, and so it's going to run. And so once this is true, it's going to run this part, and it's going to first print the statement I, and then it's going to actually change the value of the I variable. So again, as we talked about last time, one can change the values of one can change the values of these variables like in the code. Like for instance, I can reassign I the value of this previous I plus 1. So if I was like at the start 0, and if I run this, then okay, I can show an example. So if I is at the start 0, and then if I do I is equal to I plus 1, and if I print I, that's going to give me I is equal to 1 now. And so what's happening here is that it starts off at 0, but then each time it runs over the loop, it's going to increase by 1. And at some point, it's going to be more than 10 because it's being adding plus 1 like every time. And so if I run this, you can see that the value of I, which I'm printing here, it goes through each loop and prints, first it's 0, then it's 1, 2, and so on. But then at one point when it's I is 9, and when you add plus 1 to it, it becomes 10. And then no longer this statement is true because 10 is not smaller than 10. And so this while loop stops. And so that's why we see numbers being stopped at 9. If I just make 13, it's going to stop at 12. So yeah, that, that makes sense. And so yeah, these are basically while loops. Oh, one more very important comment. I think I forgot to mention this. So in all these statements, one common thing is that these statements, so again, so this is like this highlighted part is what I call the statement. And so all these statements, they're ended by a semicolon, as you can see here. A semicolon here as well. And when you have a semicolon, the code in the following line will be indented by a tab space. So for instance, if I go back here, this code is not going to run. It's going to give me, it expected an indented block. And so what this means is that your code must be spaced forward by a tab space. So by a tab space, I mean that just, press tab and it's going to go ahead, boom, like that. And so, yeah, that's what I mean by tab space. And so every single time when you have a semicolon, your code should be indented by a tab space. If not, it's going to give you an error. And so, yeah, that is very, very important. So don't forget that. Okay, so we talked about while loops. Now let's go to the next kind of loop, a for loop. Okay, for loops are, in my opinion, way more important than a while loop. Like I personally use for loops way more than a while loop. But yeah, okay. So a for loop is just, okay, so a loop, well, what it means, like it loops over something. So a for loop is that, in English, what it does is that this thing here, that is for some object in a list of objects, do something with that some object. And so I think that makes sense. But in code, it is, say you have a list, call it num list with numbers 1, 2, 3, 4. And you want to like kind of loop over every item in the list. And so in English, you would say like, for each number inside the list, print that number. So that's basically what we're doing here, is that for number in num list. So for each number in this list, num list, we get, a semicolon. And as I said, a statement is followed by a semicolon, then an indentation block here, a tab space. And then what do we do with this number in the list? Let's say we print the number. And so as you can see, if I run this code, what it does is that it goes through each object inside the list and it prints it. And so it's going to first go to the first element, 1, and then it's going to print 1. Then it loops over to the next one, and it's going to print 2, and so on. And yeah, so that's basically a for loop. Now, one thing, okay, so what is this number thing here? So what is up with this? So this number thing is just like it's just like a placeholder, you would say. So for instance, I could like just like replace number with I, and it still works. So it's just like it's just like a placeholder variable, and so that it doesn't carry that much like value in the name. But if I for instance do this print k, this won't make any sense because k is not defined, and so being consistent is important. But yeah, so that's basically a for loop. We can also like do some more kinds of for loops. For instance, here I do numpy.linspace, where again, as a reminder, what this does is that it gives me an array from 0 to 50 with 6 equally spaced points, and that's basically my array R. And if I loop over each element in R, again by doing for I in R, I printed the I, that gives me each element in the R array. So that's cool. Same with the range function, which we talked about, is that it gives us the integers between two numbers, and it's by default from 0 to like the number we input here, which is 10 here. And so if I do a for I in range 10, a print I, it's going to print from 0 to 9. So as expected. So that's good. So yeah, these are basically for loops. Again, very simple, nothing too complicated here. It's yeah, that's for loops. Okay, so now let's talk about a few examples to like make these things clear, because that's what's always going to help is like looking at more examples of this. And so, okay, so first example is let us create a list of squares of the numbers from 0 to 9. So I don't think I mentioned this earlier, but we can always, we can always define an empty list. So we talked about it, for instance, up here that we have a list, and this is not an empty list, like it has numbers in it. But I can always define an empty list which has no numbers, for instance, as I do here. A list called squares, which is empty. But then I'll be adding to it values of, so I'll be like adding to this empty list the squares. And so at the end, hopefully, this list is populated with those squares. And so the way we add stuff to a list is we do append, right? And so that's basically what we're going to do here. But again, okay, so first thing is that we want to go from numbers 0 to 9. What's the best way? Is that like, we visit each number, we find its square, and then we append it to the final list. And so that is basically what is happening here, is that, for n, again, this n is like, it's just a placeholder. It carries no meaning or value. It's just a placeholder for like the number which we're currently looping over. And so for n in range 10, as you saw above here, what that does is that it loops over every number. And so for n in range 10, I want n square, which is the square of n, to append to this empty list called squares. And so if I run this part, what's going to happen is that if you run this part and again print what squares is, you see that the squares was first an empty list, but now it has values in it, basically the squares of those numbers from 0 to 9. And so and so that's just like one instance of like using a for loop. So hopefully this was a good example to explain how to use for loops. But yeah, we will talk about this more like soon. But yeah, like once we like sort of using all these things in like a single example, that makes things more clear. But okay, so let's now go to the next part, if and else statements. So these are also again a very important part. So again, as I said, coding in Python is very intuitive. So an if statement is something along the lines of if something is true, do this. If something else is true, do that. Or else just do something else. And so that's basically what an if else statement is. And so this first case here, if 0 is less than 1, again, notice the semicolon and this tab space here. Yeah, so if 0 is less than 1, print statement is true. Else print statement is false. So what's okay, so here what's happening is that it first reads the statement. Okay, see, if this is true, it's going to run the part under the if statement. However, if this statement is false, it's going to skip this part because this wasn't true, and then it's going to run the part in the else part. And so if I run this, it's going to give me, as it's the true statement, it's going to print statement is true. But if I do, for instance, 2, that is not the case, and so it's going to print statement is false. And so that's basically how like an if else statement works. And we can also get a bit more fancy with this. So for instance, say I have a car that costs $5,000 and has a mileage of 20, for instance. I can make an if and else statement that tells me if this is a good car or not. So say my definition of a good car is that its price is less than 10,000 and its mileage is more than 10. That for me is a good car. So again, notice how I'm using this and here. So again, it's very much like English, is that if I want two conditions to be true at the same time, I use and. But yeah, so if the car price is less than 10,000 and car mileage is more than 10, it's going to print good car. If that's not true, then it's going to print it's a bad car. And so if you run this, it's going to give me this is a good car because this is at the price it's 5,000, which is good, and its mileage is more than 10, so it's a good car. So
you have low mileage standards, Varesh. How friendly of you.
Yeah. 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 But you know, it's a cheap car. But I'm kidding. Okay. Okay. Now let's do. Okay. So now, okay, we used an and statement here, but we can also use an or statement. So now, not to like make this too complicated, but and means that you both want this and this to happen. But in or, it's like either this or that. And so if you do an or statement here, what that means is that either if one of these statements are true, so if the car price is less than 10,000 or its mileage is more than 10, it's going to print a good car. So, but if both of them are false, then it's for sure a bad car. And if both of them are true, then that's still a good car. But it's an or, so it's like it's less strict. So like you're okay with just one of them being true. And so that's basically what happens here. So here, here you have like a fairly expensive car, 20,000. So it's more expensive than what you want it to be, but it has a good mileage. I mean, like, good as in like it's more than 10. And if I run this, it's going to say it's a good car. It's like just by satisfying this one part of the statement, it still thinks it's a good car. That's basically an or statement or thing here. But if I say, for instance, the mileage is 5, then it's going to be it's a bad car because both of these statements are false now. And if both of them are true, then that's again also just getting it's also going to give me it's a good car because both of them are satisfied. So okay, that's if statements. Okay, now okay. Hopefully that was clear. Yeah, now let's go through like an example of if and else statements. So let's say I want to write a number classifier. So okay, let's say that I first say okay, let's choose the number 1. And I'm going to do like a sort of like a classifier here. So let's say that if your number is more than -100, let's say that it's a good number. But if it's less than that, it's a number too small. Okay, that's our first classification. Now let's say that we wish to classify by its type, if it's positive number or if it's 0 or negative. So we can use if statements here, very, very simple. So, if number, if number is more than 0, that means it's positive. So we just want to do print again. Notice how that this block here, this indents the code by tab space here, but we have another block here. And so this indents 2 times because this, okay. So it's like a relative. Yeah. So it's like relative. So it talks about the indentation from the part where if statement starts. So this is like, a single tab, and then this starts for a single tab here. It's like that. So hopefully that makes sense. But yeah, also one can have like, if statements within if statements, like nobody's stopping you from like writing that. And so that's basically what we're going to do here is that we first wish that this number has to be positive. Sorry, that this number has to be more than -100. And then we classify furthermore based on positive or negative. And so if I do positive here, it's going to print positive. Let's do if number less than 0, it's going to print negative. And the only remaining possibility is if number is equal to 0, print 0. Okay, so we have something here. So now let's see. Let's just consider the number equal to 1. We expect that it should give us positive because first it's going to go here and it says, okay, this is a true statement. So now it's going to go here. Now here it sees that, oh, this first statement is true. And so now it's going to print positive. If I run this, it prints positive. Bingo, perfect. Now, if I do, say, for instance, -1000, that again, we expect that it to be, it first comes here. It says, okay, this number is not more than -100. So this is a false statement. And so it's going to skip this entire part and go to the else part. And else, it runs the part in the else and says it's going to print number too small. So if I run this, it prints number too small. Perfect. Okay. So yeah, that's an example of using if and else statements and like, multiple of them within each other as well. So yeah, hopefully that was a good example. Now let's talk about a very important topic, which is probably you'll be like using this in like research a lot. So here, okay, so what a loop basically does is that it loops, okay, so is that you have a list of points or like not points, like you have a list of data and you wish to like loop over each data point in that list of data. And so we talked about like okay. And to do that, based on what we have learned, there are namely 3 ways to do it. So the first way, let's look at the first way. So, okay, let's talk about, okay, so we have this list of called data of 1, 3, 5, 7. Now, the first way to loop over a list is just doing a simple for loop. Is that, you know, for x in data, print x. We run that, it's going to give us what we expect, you know, like it's going to go for each element and give us 1, 3, 5, 7, correct? Now, this is a second way to go over the same list. This may seem complicated, like, you know, why would one choose this? But turns out this is a very useful, and I'll explain like in a moment why. So, okay, so what's happening here? There are like 2 things happening here. We are calling the range function and the len function. So what's happening here is that, okay, so first it's calculating the length of the list data, which is, you know, so if I print, give me a second. So if I do length data, it's going to print 4. So it's first finding the length of the data list, and then it's finding the range of numbers from 0 to the length. And it's ranging over those values. So what is sort of happening here is that, one second, is that okay? So you have a data list, okay, the data list, and that has the elements 1, 3, 5, and 7. And as we mentioned last time, these are quantified, not quantified, but these are like labeled by their index values. And their index values are namely first one being 0, 1, 2, and 3. And so like the length of the list kind of like talks, it tells you about which index values those elements range over. So if you have a list of 4 elements, the range of the index value is going to be 0, 1, 2, 3, because it starts from 0 and it ends at, you know, the last element. So if I have, say, a list of 5 elements, it's just going to be from 0 to 4. And so as you can see, this is basically like what we used in the range function, is that it tells us, it gives us all the integers between 0 to like the ending number. And here our ending number is basically the length of the data. Like we can't go beyond the number of points we have in the list. And so here what we're doing is that we're just looping over all the index values in the list, range, len data, and we go over each index value. So if I just print this, if I do, you know, let's just do this for instance. If I do this, it's going to give me, oh, I print 0, print I, my bad. So it first goes 0, then 1, 2, 3, and then it stops. And if I do print data I, and if you remember, this is how we access a quantity in the list by putting its input index value here in place of I. And so if I print this gives me basically my list 1, 3, 5, 7. So yeah, this is like one way to do it. And why this is useful is, I think it'll be more clear when I talk about an example. So I think I'll postpone that for like a few minutes. But yeah. So here's like the second way to loop over a list. Hopefully it wasn't too complicated. The third way is using this function called as enumerate. So what this does is that first of all, it goes over it loops over each point in the list, and it's sort of like, you know, instead of looping over a single item in the list, it loops over 2 quantities, namely the actual item in the list and the index value. So if you see here, it's looping over 2 things, I, comma, x. So these are two things, I, x. And if I print ix, what this does is that it gives me 0, 1 for the first one. It gives me 1, 3 for the second one, and so on. So this I thing here, you see here, I is the index of the item in the list data, and the x is the actual item in the list. And so it prints like each sentence. It's first going to print 0, 1, then 1, 3, 2, 5, and 3, 7, so on. So the first element, index 0, is going to be 1, and so on. So okay, this is the third way. Now, it might seem like, why we want to like have this sort of convoluted way to like loop over a list. Well, here we have an example, which sort of hopefully makes it clear. So hopefully, okay. Are these, okay, so I hope that my explanations were clear enough. But yeah, now we'll talk about an example. So, okay, say we have a list of names, A, B, C, D, and we know what they're eating. But these are like things in separate lists, for A's eating a pizza, B's eating an apple, C's salad, and D's eating cake. Now, if I want to like print statements of these, like in that, what is A eating? What is B eating? One second. Okay, so say, okay, so one thing, okay, so I wish to like loop over these lists, right? So I could just do like, for n and names, print names. Oh, my bad, not print names, print n, because n is being looped over. And so as you can see here, it loops over each name. But I could also do the same for foods. But thing is, yeah, it loops for food. But then I want both of these happen at the same time. Like I want A to like A and pizza to be like in the same thing. And so what is the common thing between these two lists? Like why is A equal to pizza? Not A equal, but like why is A eating a pizza? Because is that the index value is what like, so here these like are like, these lists are ordered by like, the same index. So so like the first name is like eating the first quantity and so on. And so both of these have the same index value. So if by some way I can access the index value of the element I'm looping over, I can use that to like print the name and the food that I want. And so that is basically what I did here, is that this code right here, what this does is that, as I mentioned earlier, what this range len does is that it loops over each index value of the list. And so it loops over each index value. And then I access the name and the food corresponding to that index value. And then I say print name plus eats food. So as these all are strings, and as I mentioned last time, we can like add strings. And so if I run this, what this gives me is that, A eats pizza, B eats apple, and so on. And yeah, and so using this range len combination, this like allows me to sort of like combine the study of multiple lists into like a single loop. So hopefully its usefulness was clear, because like if we had no access to the index value, then there's like no way to tell like, how to access it. But okay, hopefully that was clear. Okay. Yeah. Also, yeah, we can like we can do the exact same example we did above, but using the enumerate function. So, same thing. This is the index value which I'm looping over, and this is the item in the list. And so, if I loop over foods, I get the index I, and so I obtain the corresponding name, and then I print that, and it gives me the same output. So good. Now we talked about for loops and if statements. Now we can also use them at the same time. So say we have like, a few names A to F, and we have their corresponding test scores. Now say I want to find the people who scored above 60%, then, what I do is I loop over all the people. But here I first loop over the index values, and then so for I in the range len names, now I like index, then I find the corresponding score, which I can obtain because I know the index value. And then if I say, again, as an if statement, so if score is more than 60, print the name. And so what's happening here is that it loops over all the names, and then it only prints the names whose scores are more than 60. And so if I run this gives me, oh, I didn't define scores, my bad. Okay. Yeah. It gives me CDE, which is where they score more than 60. Again, I can do this exact same thing by using the enumerate function, which is like, it looks slightly less messy, and so I suggest using this more than this range len. But yeah, this is how one can use for loops and if statements at the same time, like that. So yeah, so that's all about for loops and if statements. it seems like we're kind of short on time. We have 3 minutes left. I can like basically give a very quick run through the functions. So, okay, I'll do that. Okay. So this is the last topic. So yeah, it's basically the end. So, okay, functions. So we have talked about functions already. Like, function is like, it takes in an input and it gives me an output. And it's basically just like math. Like, this is y cosine x. The input or the argument is x, the y is the output, and the cosine is the actual function. And we can use either inbuilt functions as we did at the start, like using numpy.cosine, or we can write our own functions from scratch, which is basically what you will have to do in most cases, because maybe there's like some specific need for your own code or for your own purpose. And so knowing how to write your own function is also very important. So again, it's fairly intuitive. It's just like English. We first def, so we first define a function. So we first type def, and then we type the name of the function, because because you want to use that function later on. So you have to like call it a name. So here I just call it, say, your function, and then I undo bracket, and inside the bracket I mention the input. So what is the input? So I say let the input be called x, and then again I use a semicolon, again a statement, so always use a semicolon. Then you go to the following line, and then there's a tab space, and then you return something. So now this something is completely up to you, like what you want to do with x. So here I chose like a specific thing, let's say x squared. And so if I run this, now what I have is I have a function that is defined by the name of your function. So if I call this function again in the future and say I want to find the square of 25, for instance, it's giving me 625. Perfect. So this quantity here is the input. So it takes an input x, which we input into be 25 here, and then it just returns. So this is an important part of the function because it has to return something. And so it returns x squared here. And so, 25 squares 625 makes sense. I could do -1, so yeah, perfect. So that's basically a function. I will give a quick example of this other function because I think it's important. So let's say we want to write a function of finding the distance between 2 points. So I could say, let's call it distance. Now here, we just had one input, but we are by no means restricted to just a single input. We could have like multiple inputs. So as we want to find the distance between 2 points, we will need the coordinates of those 2 points. So let's call them x1, y1, and x2, y2. And first thing, the distance, as we know, coordinate a geometry, it's going to be x1 minus x2 square plus y1 minus y2 square. And I'm going to take the square root of this. So numpy also has its own square root function. So I'm going to call numpy dot square root, and I'm going to take this entire quantity's square root. So the thing is, we want the square root of this entire thing. And so that's why this square root function has to happen on this entire quantity. And so that's why we have a bracket here and a bracket here for the square root function. So, okay, so we get the distance, and then I just return distance. And then if I just, I don't know, just do some sample calculation, I don't know, let's do 0, 3, and I don't know, for 0, just do 3, 0, and 0, 4. That's going to give me 5, and which is correct. And so yeah, that's how we can use functions. What else is there about functions? Yeah. One more thing. Okay, so so here I had x1, y1, x2, y2, but say I just made a mistake and I call this x3. If I run this, and if I try to find the distance between 2 points, I don't know, it's going to give me an error. It's going to say x3 is not defined. And so it is important to make sure that all the things inside your function are defined either by some constants or they're defined by means of input through the function. So here x3 is not a constant, or it's not even inputted. But if I just make x3, if I just let's consider x3 to be always 1. If I run this, then there's no issue. And so having all the quantities inside your function that's defined is very important. And yeah, that's basically about functions. one more, I guess, one last quick thing, then I'll stop, is that we can, again, like use if statements and stuff like that within functions as well. So say I want to like, I want to like write a function that finds the hypotenuse of a triangle if I input in the two sides, say x and y. And thing is, sometimes your inputs, like, your inputs aren't like being restricted. Like I could just like, find the hypotenuse of -1 and -5, but then that makes no sense because the length is always positive. And so I could, and say, like, by accident, I input in -1, but then my answer won't make any sense. And so to make sure that does not happen, I could make an if statement inside my function that says, like, it takes an input x, y, but then if by chance my x turns out to be negative, or even my y is a negative value, then it's going to raise an issue. So this statement right here is how you raise an issue, like, or raise an error. And if this if statement is true, we have a problem, and then it's going to run. And then it's going to print, size of a triangle cannot be a negative, and then this function stops because it raises an issue. However, if this is false, then this won't ever run, and it's just going to go ahead and find and that's going to just go ahead and find the hypotenuse. So we can just take a quick live demonstration of this. So hypotenuse, let's say 3, 4, gives us 5, perfect. But if I do -3, it's going to be like, oh, value error. Sides of a triangle cannot be, they have to be positive. And so, that's how you can also write functions. So that's it for this workshop. Hopefully it wasn't too much information and it was clear. But I'm open to questions now. And also, if you have to, it's also past 7, so feel free to go if you have any, like some task or something. But thank you for listening.
Next session is Monday at 6.
Yeah, Monday at 6. Yep.
Thanks. Thank you very much.
Yep.
Sorry, this question might seem kind of basic, but I was just like, how do you open, so like you email the workbook? How do you open it?
Good question. Yeah. So, okay, so I'll stop sharing now and I'll show how to do that. Okay, so, okay, let's see. I'll stop recording. It's fine. Okay, so indecisive. Okay, let's see. I'll share my desktop. Okay, can you see my laptop?
Yeah.
Okay, so for instance, right here. Okay, so forgive my messy laptop, but this right here is this is the notebook which you want to open right here, correct? You see this here? Okay, so now what you do is you have to first launch. First, you launch. Is your laptop a Mac or a Windows? I'm curious.
Windows.
Windows. Okay, so it's fine. Yeah, so you first launch Anaconda. So just go to your search bar and just type Anaconda. And if you load it, it's gonna load Anaconda. It might take a few seconds, but it's green ring here, and then it's gonna open up. And okay, so now we're inside Anaconda. Now we're looking at a Jupyter notebook. So we should first launch a Jupyter notebook. So you see it's right here. We launch it.
Yeah.
Boom, like that. Something will happen, and then it's going to open a window. So it's going to open like a tab, and then now you're on a local server, and you basically have access to your entire laptop here. But it's not like the visual interface we have on our normal laptop. And so we have all the folders and paths here. For instance, your desktop, your documents, downloads, and so on. So now using this, you navigate to your file. So now I know that I kept my file on a desktop. So I'm going to click on desktop, and then I just find my function here, which is this one right here, Python Workshop Week 2. I'll click on that, and that's going to open up another tab, and that's basically my notebook. Boom. It might take some time to load, but right here. So is that working for you, or is that?
Yeah, I tried something like that because it said the same thing online, but I didn't like I didn't think of it as my desktop is what's on Jupyter.
Yeah,
So
it's
maybe I
yeah.
can try searching for it.
Like I think you can want to search. Like I don't think you can search like a laptop like in this Jupyter server. I think
Yeah.
you get like if like navigate. So that's why like try keeping all these
Like it's like when
notebooks.
I download it, then it's not on my desktop.
Yeah, I
So
mean,
that's
so
like
if it's yeah, if you download it, then it might be like in your
in downloads. Yeah.
downloads. So as if you
Yeah.
get downloads, it's probably there. But yeah, that's
Or
basically that's how you open a Jupyter notebook. There is like okay, so like I'm not sure how it works in the Windows. I think Will works in the window or no? Will? You
No, I have Linux.
well, okay, but yeah. So on like a Mac, there's like there's like a quick way to like do all this stuff. So I could just do like so yeah, I think it works on Windows as well. But like I'm not entirely sure what the command is. But if you're, I can just show like I probably if you can try it. So on a Windows, I believe it's the command prompt. I believe, I'm not sure what it's called. I think it's called the command prompt.
is it like the like black box thing?
Yeah. So
Yeah, it's command prompt. Yeah.
you kind of prompt. So like if you okay, I'll just share my screen again. I think it's going to be the same thing. So so if I like can just do if on a Mac it's called not the command prompt, it's called terminal. And so if I open up that box and if I just type Jupyter -notebook, I think it should work on the case, but if not, it's fine as well. But I'm just curious to see if it works or not. So if I run that, it's going to open up like a Jupyter notebook. It's like it makes all those steps of like launching Anaconda and then launching specifically notebook much easier. It all just in one single command.
Yeah, I just tried it on command prompt. It worked.
It worked out awesome. Yeah. So that's like a sure way to do it as well. So yeah.
Cool. Yeah, I think that's faster too.
Yeah, it's much faster because it sort of like skips all the steps in between.
Okay.
Yeah.
Thank you.
No worries.
Bye.
Bye.
Thank you. Bye-bye.
See you, man. See you. Bye.